Good luck.
Things. So we are live, right?
Yes.
Okay. Thanks, Nancy, again for support. Okay, welcome everyone. Today we have our fourth lesson. It's from one side a little bit sad because it's the last lesson, but from another side, it starts of something really interesting. It started your detective work on the capstone. So without further ado, let's start. So, welcome everyone to the bootcamp Bringing Machine Learning Models into Production, Lesson 4, Machine Learning Best Practices, given by you by PyLadies Amsterdam in collaboration with Dexter. So, what is awaiting for us today? First, we start as usual with a short recap, and then we switch to machine learning best practices, where we're going to discuss the scope of the ML solution again, the peculiarities of the code structure. We spend some time on tests, on the concept of pipelines, on the concept of machine learning system monitoring, and then at the end, we switch to the Capstone Energy use case. Where we will welcome Inge from Dexter, and she will present the full case for you. And the further information will be provided for you. So, okay, let's take a look what we've done so far. So, recap. What we did actually the last lesson, the previous lesson, we were working on the concept of near real-time inference in Azure. And for this, we were using serverless approach with an out-of-the-box blob trigger. So what we were doing, we started with simple template for blob triggered Azure function using Python. We updated a little bit, we update bindings and deploy it to see how it works. And then we switch on to further developing this function. And to make sure that we are doing it efficiently, we were working with Azure it locally. And then when we know that it looks like it's working right now, then at the end, we deploy this blob triggered Azure function to the Azure cloud. So nice, that's what we did before. Lesson 2, we were working on a batch inference in Azure with Azure Machine Learning Pipeline. So we tried 2 flavors of the deployments, and we also noticed, let's say, what are the disadvantages and advantages of each of the deployments. So yeah, without further ado, let's dive into the machine learning best practices. And oh, I'm hearing the birds helping me, by the way. Probably was a big nut. So we will see how it goes. Okay, so machine learning best practices. Still a lot of development taking place. Still a lot of companies trying to find out what's the best way to do machine learning, what's the best way to embed AI practices into the enterprise life or even in the life of the small startup. And there are millions of tools, there are myriads of different libraries created to do some orchestration or simplification of some specific processes. So it's literally a lot of things going on right now. So to make sure that we know, let's say, what the best is and at least where to find the most interesting information or the most useful information about this, let's start. And of course, last time we were talking, the first lesson we were talking that we never start a use case with let's deploy model. It's not the end goal. Usually the model is only a tiny cog in the whole ecosystem. So I will repeat it again and again and again. It doesn't matter what you're starting, usually define the main goal. And it's really, really important because the goal is not to deploy the model. The goal is to solve something or to improve something or to update something. And how you're going to do it, probably there will be a place for ML model, probably not. So when we define the specific goal, if we look back at what we've done so far, it was the deployment of an energy consumption or energy load model. How this model can be used, in which way. Should it be a part of a dashboard? Should be a part of a specific pipeline that will update data and notify people who are responsible for energy delivery to, let's say, increase the load or decrease the load in electrical grid? We didn't know. We were so concerned with deployment part that we completely forgot about, okay, what we are doing, why do we want to deploy it? So main goal, it should be your North Star. Main goal, it should be your guiding line. And when we're talking about ML solution development, ML solution, it's not only one model in vacuum. ML solution, it's the whole concept around it. And sometimes we can end up without doing any machine learning at all, just some specific naive forecast or specific business rules, business logics can solve a task for us. So when we're starting with ML solution development, there is a 3-step approach to do it. When you start to visualizing your ideal solution and you try to be as crazy as possible without taking a look at any constraint that you have. So what do we want to do? So if our goal is to improve the life of the energy grid operators, then probably they need a dashboard. So how this dashboard could look like, or should be an application, or how they're going to use it. So let's visualize it and think about it as vividly as possible. And then the next step is really get back to the ground and understand how the real problems really solved. So what do they have right now and what doesn't work and why they want this improvement? And only after that, we're going to design the specific solution, an app, or a dashboard or something different, taking into account all technical and non-technical constraints. So we're starting with being really, really vivid, really, really crazy about it. Then we go narrow down, okay, what we have right now, how we can improve what do we have right now. We don't want to reinvent the wheel. And then we go to some specific design, or we're gonna redesign the app, or we're gonna redesign the dashboard, or probably just make the dashboard real time instead of updating it once per week. There are different options. And of course, the third step, one of the most important steps, is as soon as you try out and you know, okay, probably it looks like it's working, it's time to start going to this MVP part and do it end-to-end iterations. And what do you mean by end-to-end iterations? You want to make sure that the data that you use for your model and the data that you expected to get, these data are available. In our case, when we're working with data, we were getting data every hour. And this data were only including the load on the energy grid. As well, we were working with weather data, and we had temperature and precipitation. So in case you created this application or a dashboard or something that using predictions from your model, you want to make sure that if you want to update your dashboards every hour, then you have all the data to do these updates. And if you say, okay, I want to have it near real time, I want to have like updates every 5 seconds, you need to make sure that you are capable of getting this data every 5 seconds. And a little teaser, in the capstone, you will see the difference. So if we miss some specific data, then we have constraints. It means that we are not capable to actually deploy the best model that we have, only because the data are not there. And also what I want to mention here about this end-to-end MVP iterations, that sometimes I was working on the projects where everybody literally forgot what was the goal, what we are doing. All tasks were about, we need to deploy the model, we need to deploy it, but what we are trying to solve with it, why do we need to deploy it? And then you start to learn that actually the data scientists already left the company, and some of the business people who are responsible for this project left the company as well. And we're doing it just like kind of, like using inertia, something like this. And it was really, really strange. So I know that probably it sounds boring, but if you're doing something, you need to know what you're doing, why do you're doing it, how you're going to approach and develop it, and iterate, starting with something simple, stupid, just random model, just like that performs better than random, like, or some simple business rules and logic, and just to improve it, to improve it, to improve it, to improve it. Also, what's interesting to say in the field of energy, although there are a lot of wonderful papers about how we can streamline the energy forecast with the power of deep learning, or how we can do it with the power of different machine learning models, in the majority of the cases, the company is still using simple business rules because it's just good enough and it gives less errors than the machine learning and deep learning models. So yeah, end-to-end iterations is really, really important, because our goal is not to deploy a model. Our goal is to bring value. But with all that said, you say, okay, cool, I understand this, but what's next? So what next is actually a code structure. And it's really, really important part of it, because when you write a piece of code, first of all, you're writing it for yourself, and it's you who gonna read this code tomorrow, who gonna read this code in a week, or who gonna read this code in 2-3 weeks or a month. And if you're not capable of remembering and understanding what you've written, neither other people can do this. So I would love to start with this notebooks within modular codes. I'm not saying that notebooks are bad or notebooks are good. There are different companies that have the notebooks running in production. There are different solutions how to orchestrate, automate them, validate them. What I'm trying to say here, that the issue with notebooks is if you don't use them in the right way, they teach you bad coding practices. And it's just an example, and that's what you usually see when you get a notebook. There are a lot of repetitive code that could probably just formulate it as a small function. And if you run this function, then you don't need to write and copy the same cells again, and again. And there are a lot of videos online, a lot of articles about notebooks versus Python scripts, when to do what. What I want to share with you from my own practice, from my own perspective, notebooks are really great for exploration work. Notebooks are really great for different visualization works. And you can also have some structure even using notebooks. In the lesson 2, we used to work with notebooks. In lesson 3, we didn't use notebooks at all. So in lesson 2, we had separate notebooks per specific task, and it's a really good practice to keep them separately. So we had a separate notebook for the data preparation. We had a separate notebook for training of a linear regression. We have a separate notebook for training of the reach. We have a separate notebook for model evaluation, separate notebook for data preparation for the batch, and separate notebook for the pipeline. So remember that each notebook has its markdown cells, so use it to add important information there. And then if you're just playing around and exploring something, is great and it's okay. But if you want to move to a way of modularity, when you can run functions that could be reused probably by other data scientists or by other of your colleagues, do this. And another thing that I want to add here about the modularity, probably you heard about spaghetti code. So what is spaghetti code is, you see like a small example of it just right now on the screen. Okay, here just do repetitive task again and again and again, but then if somehow you're gonna run the notebook not in the specific order, and then if you change something in one place and it's the rest of your code will fail, congratulations, you got your spaghetti code. And how to get rid of this spaghetti code is exactly to go into the direction of small functions, probably using object-oriented programming concept with classes, methods, and attributes as well. And if you want to have inspiration where to look for the good quality code, I usually advise to go and just explore the code of the libraries that you're using, such as scikit-learn, pandas. If you just go to the GitHub and you find the main repository of pandas, you can explore how each methods that you're using in your code were written by other people. Also, committing to the open source, it's a good first step to start writing the good quality code. The next thing that I want to say is the issue with unpinned libraries. So in lesson 2 and lesson 3, we were working with conda environments. In lesson 2, we are working with conda environment where we were dependent on a specific version of Python that we installed. Then we loaded specific libraries via conda that we need, and the rest of the libraries that are not available via conda distributions, we actually downloaded with pip. And the problem with this approach is that from one side, conda is a really good tool. It's a really good tool because it helps you to manage different dependencies and make sure that your environment is stable. And also, if you're working with non-Pythonic libraries, which require some specific, let's say, backend in different code, it's a really good tool to use. On top of it, the conda is great in making sure that you can have a myriad of versions of Python on your local machine without broken let's say, the tools available in each environment. So what we did last time in lesson 2, we didn't pin our libraries. And let me tell you what happened next. If you don't pin your libraries, every time the new update of the library will be available, conda will pick it up. And if you have different operational systems, sometimes conda made a release for a specific version of the library, but the time of release is different for Linux, for Linux distribution, for Windows distribution, for the rest. So if you have a situation where you, as a data scientist, you're working on a Windows laptop, you're writing your code using conda, great, and you using some specific libraries. Then when you give the scope, for example, for DevOps engineers, machine learning engineers, or other people who's responsible for machine learning deployment as your company, they get your conda file, they know exactly which library should be installed, they start testing it, and they notice in it that they have issues. And trust me, the 85% of the bugs in production environment usually caused by unpinned libraries. And it's not just the issue of conda, it's the issue of requirements txt files as well. Another example, different versions of the libraries has different methods deprecated. So in lesson 2, we were using a combination of one-hot encoding and column transformer mixing class. If you look back at, let's say, 2 or 3 versions of scikit-learn before, there was another way to do it. And if you try to do it in that way, and you don't take attention on the version of the libraries that you're using, that when your code will be in production, it will be broken. It will not work at all. So my 5 cents here, pin the libraries. Or you're working with conda environment, or you're working with pip, it's better to pin them and then safely testing whether increase of the version of libraries breaks something. Another thing in lesson 2, while you are running this environment that you see on the screen right now are like famous MLOps train environments, you come across a lot of warnings. And it was saying something like, your pip version is old, please update your pip version. And for those who probably dare to update it, it was really, really bad consequences. Because if you're using the latest version of pip, so you're literally adding pip as a dependency, in the conda, then you get another versions of library downloaded via pip. Then it got a conflict with the libraries. Then Conda tried to solve this conflict for you and downgrade some of other libraries. And what you get, guess what? Not working code. So I would like to say it once again, pin the libraries. Another story, if you want to prevent the situation, okay, it works in my machine, it doesn't work anywhere. Another option how to handle it is just to use Docker. But also with Docker, there is another story, have different versions of, for example, Python Docker images. And based on which image you want to use, there are also some consequences. So to sum up this part, doesn't matter what you're using, Conda, or you're using requirements.txt pip, or you're using, for example, you define everything with poetry. There are different versions. Always try to pin the libraries. And for local development, you can as well use the Docker. Another story is about documentation, type hinting, and the usage of pre-commit. So documentation is always useful because sometimes some of the functions could be really tricky to read. I'm not saying right now it's bad or great function, doesn't matter, but sometimes the documentation adds something to it. What is important here to mention that in case with the Visual Studio Codes, you can install an extra extension. And with this extra extension, if you're using type hints, you can auto-generate the documentation. So literally get nice, good-looking documentation parts that could be used further for creating nice documentation around your code. What's nice about type hinting? Just an example on the screen how the type hinting make your code more readable. So if you just create a specific function, you say, okay, I assume that this function take two arguments, A and B, and my assumption is that this function return concatenation of these two arguments. So the instance of the A argument and B. And I see that I'm actually calling two specific methods. On A, I call in lower methods, and on B, I call in upper methods. Okay, of course, you can be more verbose and say, okay, this function makes lower uppercase, then the function has first parameter, second parameter, and that's what you return. Yeah, probably doesn't say a lot, but the next line, these are the type hints where you actually define what you expect to have. Python actually will not look at it. So if you use, instead of first parameter, you define it as a string, and if you use something different, it will not give any objections. But later, when I will tell you about pre-commit, you will see why it's important to do. So in this case, if you are using type hints, you're just defining what kind of object you expect to get out. So you see that I'm saying mix lower uppercase. The first parameter I expect it to be a string. The second parameter I expect it to be a string. And the return, the result of the function, should be a string as well. Then I add just a simple one-line docstring, and I'm saying, okay, I concatenate two strings, cast the first string to lowercase and the second string to uppercase. So, but you want to make sure that what if instead of string, I'm going to drop some integers or floats. So for this one, you want to make sure that if you're expecting strings and you want to get a string out, then you can add a typecasting to your function. In this case, you just say, okay, I'm expecting this first parameter is a string, so then I can call lower it, because if it will be integer doesn't has a lower method, and you will get an error, so your code will be broken. And so type hinting is actually defining in this case, what are the objects that you're using, what are the Python objects that you're using, and what your function is expected to return. And the beauty of pre-commit is, if you set up pre-commit and you use it locally, and for example, during merges with a master, pre-commit can contain a bunch of different linters, formatters, such as black, such as PyLint, Flake, and MyPy. And the added value of this is that your code, it doesn't matter who's writing the code, will be looking, let's say, like the same, because formatter will format the code for you to make sure that it's adhered to the PEP standards. And if there are some issues, you will be pointed to these issues. And in case with MyPy, if you're using type hints, MyPy will not allow literally to commit your code until you fix the issues. So if somewhere you define the function where it takes 2 parameters as strings and it returns strings, and if somewhere in your code there is actually a parameter such as integer or boolean or something like this popping up, that's where MyPy gives you a warning. It's like an extra safety net for your code. And for those who prefer to use double quotes instead of single quotes, the black will format is for you. So that's the beauty of a small automation in your case. Another story is about print vessel logging and error handling. So we were so much in rush during lesson 2 and lesson 3 that we didn't spend time on explanations what's exactly the difference between using print and logging. In lesson 2, we were using print everywhere. In lesson 3, we were using logging. The difference is here that if you're going to run a production grade code, you need to make sure that you're using logging, because based on what you define in logging, you can define a level of the logging. Is it an error? Is it just information? Is it just for debug purposes? Do you want to have more verbose output or not? And based on that, you can define and calculate specific metrics as well. And with logging, you can exactly say where do you want to save your logs. And trust me, logs, there will be only one guidance for you during the production. So if something goes wrong, only with logs, you can understand what's happening there. And the right balance between a lot of logs and less of logs, it's always hard to find. It will be always a learning point, because if you do a lot of logging, it requires some storage because you need to store logs somewhere. And the process of parsing and processing logs is usually pretty painful. From another side is if it will be not enough logging in your code, then you will don't know what's happening. And if your code will be given errors and failing, it's better to learn about it at the beginning than at the end of really expensive GPU compute. And about error handling, if you look at the code that we were writing in lesson 2 and lesson 3, we were not doing error handling at all. So we were expecting that everything that we write in code should be as it is. If we were expecting that we load a model and then we deserialize this model with job bleep, we were expecting that it's true. But in real life, you can get all other types of errors. And that's the question for you. How do you want your code to perform? Do you want that it just throws some random errors and you don't understand what to do with it? Or do you want to get a specific error handling approach and specific exceptions and errors that where you can actually stop your code and you can save pretty expensive compute resources? Especially imagine if you're running, and like we did in lesson 2, it was a pipeline. In our case, it was pretty quick pipeline. It was just picking up and reading 168 files, then loading model, then transform these files into NumPy arrays, reshaping it, given to the models. Models gave us predictions back, and we were processing these predictions and writing to a TXT file. That's what we're doing during the pipeline. And imagine that if you have pipeline to train a model, and if you want to train a model and try different sets of hyperparameters, and you know that is pretty expensive computation, and you want to just start it and make sure that in the morning when you came back, it will be done. Do you want to come in the morning and learn that it fails somewhere and it was let's say literally running, retrying and giving lots of errors, but delivered 0 results? Or it stopped at the beginning, throw a specific exception error, and your code was stopped and your compute resource were saved. So just a simple case of try except case when you, in the try case, you define in the function what do you expect what do you expect to happen, and then you define a specific types of errors. You can reuse errors that already exist, and of course you can write your own errors. I usually use it a lot, especially during the series of models deployments. Sometimes we define a specific error specific to particular types of the models. So you know exactly if something goes wrong, you know where it is and what to do with it. So in this case, in try case, you say that you expect that you can actually use a division and that you can divide A and B. But then you say if there is some specific, if for example B is 0, you get a 0 division error. This is really handful when your model requires specific input. So in case you start with pandas read CSV, you want to catch all exceptions here, and you want to catch an exception that if file not found, you catch it with no file not found error. If the model couldn't be found, you catch it as well with file not found error because you serialized your model as a pickle. So all different types of exception that can go wrong could be cached with the exceptions. And it's also something really good to remember about it. Another story is the usage of sys library or argparse, config argparse, click typer, and all other types of CLI. In lesson 2, we had all notebooks except one Python file. So we have Python file to evaluate the models. And to run these files from the command line, we were calling Python run this file, and then we were given an argument. So in the file, we were using sys library that allows us to read and parse arguments from the command line and use them as a specific variable in your code. Sys is a really nice library. It's built in. But if you want to add a specific set of parameters that you don't want to hard code in your code, it will be a little bit complicated. So for this, you can use argparse, or let's say like upgraded version of it, config argparse. And what you're doing exactly, you define specific set of parameters. You can define default. So if you just run Python file, that's what you get. Or if you want to experiment from the command line with specific components in it, for example, different hyperparameters, or picking up specific version of the model. So instead of going to the code and where it's hard-coded, rename the model that is really, really error-prone, and that's what we were doing in lesson 2. In lesson 3, we were literally pointing to the specific model path, and we were expecting the models there. And if you do typo, and instead of spelling linear regression, you will spell it with underscore instead of dash or something like this, you get an error. Your file will not run. In this case, you can do still the same things in the command line, but now what's nice, you don't need to go to the code, hard code specific elements, and then go again and again and again with specific arguments. There are different versions of it, which to choose. It depends on your circumstances, on how much arguments you want to add, what is the best way to do it. For example, my 2 favorites are config argparse and typer. I use this for different purposes. If I work with config argparse, I usually define a specific config file where there are different setup for dev, for a testing environment, for staging environments, and for production environments, where different arguments are used for specific use cases. And then I can just read it from config argparse, just giving one specific argument. In this case, it will be environments, and then it picks up all arguments from it automatically. Or typer or click. So there are different versions how to do it, what kind of value it will add to your code, less hard coding, and give you the space with more experimentation and making your code more robust, and also an opportunity to orchestrate your code with different orchestrators when you can literally in the pipeline define specific arguments that you want to run, and it will do the magic for you instead of going and literally rewriting some specific variables in the code again and again and again. And especially it's really, really useful if you are want to evaluate different types of models, or it's really, really useful if you want to play around with different hyperparameters. So when you want to keep some specific hyperparameters fixed and other ones to be changed. So go and explore. There are different options. One of the options will work for you. Take your time. Another story is automation. And what do you mean by that? If I need to do something once, probably I just do it in one way. If I need to do the same task twice, I will start thinking, is this a repetitive task that could be automated? Or I can do something, or it's like just some coincidence. But if I came across this task 3 times, that's where I'm gonna automate it. In my case, what it's example of parts of a makefile. I'm a big fan also of using makefiles. Usually you can use them on Linux or Mac because it's like Unix system. You can run them on Windows as well, but it requires some extra installations to use them. But what's nice in using makefiles, you literally define the set of commands, the CLI commands that could be run, and then you can bundle it together to make sure that you can do specific like run test or clean repository. So if we look back at task 2 and task 3, lesson 2 and lesson 3, in lesson 2, while we finished lesson 2, we had a lot of things in our repository, a lot of different artifacts like PyCache from virtual environments, some intermediary folders. So if we want to remove them, we need to clean it literally by hand. But in case if we are using makefile, we can just literally type a make clean command in the command line, and it works like magic. It cleans it for you. Where the make files also useful, for example, you're working on a specific data ingestion for the machine learning, you're just starting, and you know there's a specific set of repetitive actions like go there, call this API, get this data set here. And if you know that it's a repetitive task, it's also a really good candidate to automate with makefile. Another story, if you're working or with conda environments, for example, there is some specific steps should be done to create conda environments or to update conda environment, to activate conda environments, and then after you stop working with a conda environment, to remove it, for example, if you don't need it anymore. Or as we did in lesson 2, we were installing IP kernel to make sure that you can run Jupyter notebooks and use IP kernel from our conda environments. And then if you want just to clean it up, you need to do a lot of commands. But with makefile, you can just say, for example, make remove. And if you bundle remove environment and remove kernel together, it makes sure that you get the cleaned repository. And there are a lot more things where you can automate stuff. There are a lot of options, but the makefiles are one, I think, of the simplest, shortest and easiest to use. So let's take a look briefly what we cover in a code structure. So we briefly discuss notebooks, what Git was passed, and the modularity of the code when you split your code in functions, or you split your code in classes with specific attributes and methods. Then we just briefly take a look at the conda environment and like situation with conda environments or virtual environments when it's really advisable to pin the libraries. Otherwise, the stuff will be breaking in production when one of the specific, for example, pandas commands or scikit-learn commands are not used anymore, and as well the usage of a Docker. Then we briefly take a look at the documentation, at type hinting, and the pre-commits. Then we move to difference between print and logging. Just like an example of error handling with try except case, or we can use as well as search statements. Then we'll take a look at running Python files from a command line with usage of different libraries and tools for it. And the last piece was about automation, in this case with makefiles. By the way, for those who are wondering where I can find all the links to all these tools, how I can use these tools, I added a really beautiful link on the reading materials. There is a wonderful person who spends a lot of time not only working, but also committing to the open source. And this amazing person has a Calm Code project. I highly recommend to investigate it because it contains a small pieces of wisdom that makes your life as a Python developer much easier. It contains a set of small videos. It's free of charge, and he is usually updating this and adding there a nice addition. So feel free to explore it and see the best practices. And also, if you're confused and you don't know where to start, if you're just Googling example of type hinting, you can always find more information about it. Okay, but the most neglected part usually it's the tests. And when I'm talking about the tests, the hard part is that while doing and running any machine learning projects, we require at least 3 times more tests than the usual project. Why? Because we test in our code, but we also need to test the data and we need to test a model. We were so much in a rush in lesson 2 and lesson 3 that we completely neglected this part. And trust me, probably you can manage to deploy something, but if you don't have at least basic test coverage, in the majority of these cases, this code will not be allowed to go into production environments. Or if it somehow ended up in production environments, then it's really, really hard situation. So let's take a look briefly at the tests. Although this topic requires a lot of hours and workshops to go through, but let's try to cover the 3 pillars, exactly the code test, the data-specific test, and model-specific test. And as well, there are some links waiting for you at our GitHub repository for this bootcamp, where to search for this. So regarding test, also, if your code is modular, so if you have tiny small functions, then you can write the tests, and it's exactly writing functions to test your functions. If you start with unit test, it sounds a little bit weird. So once again, let me repeat it. You write a function to test your just written function. A lot of people asking, why should we do this? Like, why should I spend a lot of time on doing it? And especially when you're working with unit test for specific pandas transformations, sometimes it looks really, really verbose. But only then, when it's time to do some updates, they see the beauty of the test and they can realize the value of it. So regarding tests, when you're gonna run different machine learning projects, there's a high chance that you will usually start with unit tests. And unit tests, that's exactly when you write a function to test your function. There are just some examples. It's from one of my workshops, if I'm not mistaken. Yeah. So at the bottom, there is just a function that do specific things. This function, by the way, is using type hints. So you see the name of the function is filter not equal. Then you define the parameters. The first parameter df is a pandas data frame. The second parameter column name is a string. And then you have a specific value and it's integer. And you want to get pandas data frame back. So what this function is doing is making a copy of your data frame. By the way, it's not deep copy. So good luck with it, but it's another story. And then it's just pick up specific condition, and based on this condition, it just creating a subset of your data frame. And then we have we're using PyTest here just to do some testing with this function. We want to make sure that this, for example, function gonna work when our filter will be 2. Then we want to test it, then it will be 0. Then we want to test that in case we are just adding the column or try to verify the column that doesn't exist, it throws an error. So literally, we go through different use cases. Why it's useful, you can ask. It's useful because in your code, you will be doing a lot of data transformation. You will be fill in missing values, you will be probably removing outliers, you will be checking or doing some specific condition-based filtering. And what do you want to have? You want to make sure that the data are going there as expected, and then the data that are prepared to be put into the machine learning model to give an output in a specific way that is expected by the model. So if the model is expected an NumPy array, that you give this NumPy array to the model. Also, you want to check that this NumPy array is not empty. And all these things, we call this edge cases, to make sure that your code will work. And if you're done with unit tests, usually it's really hard to cover all functions if you have a lot of them. So the best way to do it, pick up the most important function that is responsible for the key moment in your data transformation and test them. Integration tests, there are different definitions for it. In this case, if we having a data pre-processing setup, for example, we ingest data, we do some joins, we are cleaning up the data. So in this case, integration test can test a bundle of functions in once. And you also can use a PyTest framework with it, where you just define what you expect to get in and what you expect to get out of it. Then you have a functional testing that's tried to test the whole pipeline end to end. And then based on the type of deployment you're using, there will be different types of tests as well on top of it. So yes, indeed, a lot of tests, but how on earth we will know that our code is working if we don't even try to test it? And then, for example, in the situation where it's not about the first time model deployment, but it's about the you want to retrain the model, you want to upgrade the model, you want to add a new model, then that's where the regression tests come into place, where you want to make sure that the predictions of the model, different model on the same data, doesn't have a huge difference. So it's a lot of testing. Once again, it's not easy topics. Each topic requires at least some hours on its own. So my advice is, if you're going to split your code into small functions, start just in the beginning with small unit tests where you test your function and you know at least that the function returns what you expect to get from it. And then, for example, for different types of deployment, as I mentioned, if you're working with, if you deploy a function and expose it via RESTful APIs, that comes in other things like load testing. But for now, we didn't work with APIs in this bootcamp. In our case, if we just have unit tests, it will be a really good starting point. But okay, it's clear. So there is a code that we write for doing some specific data transformation. There is a code that we write to get some predictions back. But what about data tests? And what is data-specific test? So the problem with data is that if you're working with the structured data, and if the data is delivered by another department or by another people, sometimes some things could be changed. For example, even the name of the CSV files or Parquet files or Abra files could be changed. And if you're sensitive to the name, then you get a broken pipeline. Then you want to make sure that your data is valid. So if you're expecting a CSV file that could be read in and that could be actually transformed into the, let's say, data frame with specific amount of columns, and you expect specific data types per column, that's exactly when you can and you want to validate your data. And it's really important because usually with simple tests, it's really hard to catch. Otherwise, you need to write a lot of functions to make sure that you can validate your data frame. So in this case, to make your life a little bit easier, there is a beautiful library. I also provide a link to it in the materials. It calls Great Expectations. And what Great Expectation is doing, it lets you actually check the validity of your data. And on the screen, you see just an example of usage of Great Expectations, why you're creating your own expectations, so why creating your own things to check. Probably it sounds a little bit complex right now, but their documentation is really great. I highly advise you to go and check it. And usually in a lot of data pipelines that pumping, processing, transforming, and cleaning data from machine learning model, I usually use great expectations to make sure that the data you're getting has a specific, let's say, are according to the specific data specific data requirements. So that's about data-specific tests. You can also test even more, but some of them you can cover with basic unit tests. And in this case, when you want to check the validity of your data, I highly advise you to use Great Expectations. And by the way, they're also looking for open source contributors. So next thing is model-specific tests. And what do you mean by model-specific tests? Usually you know at least what kind of output you expect to get out from your model. So if you're working with regression model, then probably there is specific range of values that you can get out from it. And if you're working with classification, there is probably some, let's say, something between 0 and 1 that you that you do want to expect. And that's exactly what you can do. The model-specific tests, it's not... So let me rephrase it. The model-specific test could be done with the same PyTest as well. So you can use PyTest for unit test, and model-specific test will be a kind of unit test as well. But here, what you're going to check, you're going to test your model. And in this case, what do you want to check? You want to check that the model output, for example, has the specific expected values or range of values and has a specific shape. So if you know there is a NumPy array that the shapes correspond to the reality. On top of it, you want to make sure that if you load in your model, then it gives you back exactly what you want. So remember in lesson 2, we were actually using 2 pipelines. One pipeline was for linear regression model. It contains the preprocessing step with column transformer with one-hot encoder. Then the next step was to apply linear regression, and reach was also with one-hot encoder, column transformer first, and then it was the temporal train test splits, and then it was the reach model, and then it was some evaluation as well, and some transformation at the end as well. So here, what do you want to test? You want to test if you pickle your model, and for example, if you used scikit-learn library and you pickle it as a pipeline artifact, then when you load in this artifact, you get back exactly what you want and not something different. And another thing that could be tested for the model as well as, for example, that your model returns exactly what you expect to get, exactly the same object with a specific shape, with the specific values. If you load your model, you get back exactly what you expect to unpickle, and other type of the tests that could be done. In case you have a model that is pretty compute intensive, for example, if you're working with forecasting with profit, sometimes it could take a really, really long time to get predictions back. In this case, you can use a mock part of this of the PyTest, where you can actually fake your model. So if you working with classification model, you can just create like a let's say fake function that just gonna accept some data and gonna give back randomly 0, 1, something like this, and you can use it for specific cases as well. So there are a lot of so-called magic, but it's really, really important to use it as well. So if we're looking at the tests, there are different types of tests involved. Tests just to make sure that you try to catch up all, let's say, edge cases of some specific things in your code, as well as some bugs. And then there are a specific set of tests dedicated to the validity of your data. It's so-called data-specific test, and it's really good to use Great Expectations library for it. And then for a model-specific test, you can just be really good with PyTest. So that's about testing. There's also component classic code coverage. Of course, the aim is to have the majority of the functions covered and have the basic integration tests in place. But let's start just with basic unit tests, add some data-specific tests to make sure that the data that going into your model are in the right weight. It's created and transformed in the right way as you expected, with all the features that should be there. And then for the model-specific test, it's more like a sanity for the model to make sure that it's doing what it's doing. And where you're going to use test, when you go, for example, from dev to testing environment, that's where your pipeline can contain specific tests to be run to make sure that the code you want to merge with the master is according to your requirements. So that's about the testing. Usually it's the most neglected part. We don't have time, we're in a rush, we want to do this, we want to do that, we're forgetting about it. But it's really, really crucial part of it, because if you want to change or pivot something, you can only do it really good if you have your test set there. Otherwise, you will be just randomly guessing. And with test, you can do a lot of automation as well, because if you know that all tests are passed, then you're good to go to the next stage. And another thing is about pipelines. I usually look at the whole ML system as just a bunch of specific pipelines that starting with a pumping data from somewhere, then doing some specific things, and in case of inference, just generated predictions and reprocessing. And it's nice to think in the concept of pipelines, because then you understand all the data movements, and then if you want to update or reduce something, you know what the dependencies are. On top of it, while working with lesson 2 on Azure Inference in a batch mode, we were using the concept of the pipelines. We were working with Azure Machine Learning pipelines, and that's where you saw that in a Python code, you can define a specific steps, the order of the steps, or have some steps in parallel. Then you can run and you get your results done. In our case, we were just running the step get data, and another step was to spin up Docker container, put your code in the Docker container, run it, and the third step was in parallel, so spin up not 1 but 2 or more containers, and in these containers process these 168 files, and then give us result back and combine this result. So that's, let's say, the concept of pipelines. And for those who are really curious about what other possibilities of Azure Machine Learning pipelines, that's where you saw there was a lot of other steps that could be included. So in a nutshell, when we're talking about pipelines, I usually prefer to start with the so-called data ops or data operations. And that's exactly where you get data, you do some specific joins if it's necessary, you do some specific data validations, you do some data preparations, cleaning, and then you do split or transformations, and then you do at the end the feature engineering. So in our case, in lesson 2, we were assuming that creating of lagging values, it's not a part of our machine learning pipeline. And we were expecting all the CSV files with data that they already contain in all these lagged features. But the question is, should it be a part of the whole pipeline, or should it be separately? Yeah, it's a really good question. If you have a huge company and you have a set of data engineers working in your team, then probably you will focus more on a model part, and your responsibility will start as soon as data are delivered by data engineers to a specific place based on the provided requirements by you. If you're in a small startup and you're doing everything on your own, this will be your responsibility to make sure that if you want to train this model, you need to get this data from here, you need to call this API to get weather data, you need to call this to get this type of data, then you need to do cleaning, validation. Of course, if you're working with different time zones, to make sure that the data also, let's say, and the time zones are converted, and then you know that you're operating the same set of data. So the data ops could be a separate part of pipelines, or it could be a part of your machine learning pipeline. And also, sometimes if you're working with different types of models, probably you will have a specific feature engineer per models. So that's why sometimes it's useful to actually distinguish between where the data processing starts and stops, and where the model part starts and stops. Another thing is about model training, and it includes a lot of factors based on what kind of model you're going to train, how you're going to train it. Is it really a compute-hungry model or not? There are different ways how you can orchestrate the whole model training process, and you also can automate it. And that's the beauty of pipelines, because you can say that as soon as data cleans, processed, prepared, landed up here, start your model training. And then as soon as the model training stopped, do the next step. That's the beauty of the pipelines orchestration. In our case, we were not training machine learning model as a part of pipeline. We were concentrated mostly on the inference pipeline. But it's as well a good thing to know about that it could be a training pipeline as well, or it could be the whole set in once. And there's also a concept of so-called feature stores. So in case you need to do some specific predictions where you can calculate some things on the go, on the fly, and the rest of the things required really hardcore, highly compute-intensive calculations, that's where a feature store can come into place. And you can pick up features from there and use them for model predictions. So the thing that is really important here, if we're talking about the model training pipeline, it's exactly the model evaluation. So in our case, in lesson 2, we had the model evaluation part separately. It was a separate script that was running, but with the pipeline, we actually could we could link each parts together and have the full blown model training, data processing, model training, and model evaluation steps. And here, a lot of things happening actually, because what you want to do, you want to make sure that your model evaluation not only has good metrics as you define, for example, in case with regression case, the specific types of metrics that you pick up, and you compare models on the specific matter. But you also want to make sure that your model is ready for a further deployment, and you're really cautious about performance of the model, about the size of this model, about the how compute intensive this model is. And also remember, in lesson 1, we discussed the really important step is exactly model interpretability and how to catch specific biases in your model and specific biases in your data. And somebody asked in the lesson 1, okay, what kind of biased data we could have with energy data? Come on, it's just like the energy data. And a good example of biased data was if we had a data set that has contain, for example, a postcodes, and if we know that for specific countries there is a differentiation regarding the level of life per specific zip code or postcode, that's exactly when the bias start crawling into your data set. And that's where you can say, oh, probably for this region where like the poor people live in, we can just give less electricity. They don't need a lot of electricity, such as like rich people. So that's just a good plain example from scratch when you don't have, let's say, the gender data or nationality data, but you have as well like this specific postcodes that could play a really, really tricky role here. And then another things such as time to develop, time to retrain, and what kind of maintenance is there. And that's what is usually really neglected during the model evaluation. Usually the model evaluation, if it's orchestrated, is all about compare some metrics, compare its performance with other models, and just register this model and deploy. But the steps such as interpretability, biases, and other are completely skipped. Because of the lack of the time, of course. And the last part, the model deployment, as you see, there are different options, different versions how we deploy the model. We just tried the tip of the iceberg, actually, with our 2 options of the batch inference and near real-time inference. But then the whole process of model deployment could be orchestrated as well. And there could be a set of specific pipelines. They're going to make sure that it creates a reproducible environment. It run the code, you check the data quality, you check the data validity, you check the performance of your model, you check the specific metrics, and then you get back with some results. And if it's all passed, then it's a good candidate to be released into other environment, for example, from dev to testing, from testing to staging, and probably then with some like manual gates when the chief data scientist or somebody else, I don't know, like product owner, will give it permission to release this model to actually the production environment. So regarding pipelines, I'm a big fan of pipelines. If you just start experimenting around it and you're in the first stages of data exploration, probably that's where you don't need a pipelines. But as soon as there is specific shape in what you're doing, and you know exactly how the data are retrieved, how the data are processed, how the data are prepared, what kind of model could be training. Remember, we're starting with a simple baseline. We're not going immediately to the deep learning. Probably we don't need it at all. And then we go to the specific set of model evaluation. And then based on the use case, based on their machine learning solution, we go into the model deployment part. So with all this said, another most important thing is really neglected is machine learning system monitoring. And the problem with it is that, unfortunately, I don't have a one straight answer for all of you. How monitor my models? Because there are so many use cases of deployment with different things that has influence on how the model could be monitored. So overall, when we're talking about machine learning system monitoring, we covering usually so-called technical monitoring, or as we call system health. That's things around, what we're going to do with, let's say what we're going to do with, like, is it CPU okay? Are we not running out of memory? If we take a look at, for example, the batch deployment, is it the batch deployment fails or not? Is it like the container was spun up properly? In case with Azure Functions, it was whether our Azure Functions failed or not, whether our function dropped the data where it's expected to be there. So it's all about like the basic technical things. And that's exactly where a lot of companies are stopping in their system monitoring. They say, okay, for example, if we run in Kubernetes, probably, or there's a high probability that the Prometheus will be used in, let's say, in combination with Grafana, just to monitor what's happened there, like CPU, RAM, and the rest of it. If it's RESTful API, the number of requests, the number of failed requests. But there is nothing about the model performance in it. And that's a pity, because every model that is in production right now is decaying every day, bit by bit. And what's happening, because the model performance, there are a lot of drift, as you see, that's happening. And there are different ways how to measure this drift. And there are different types of drift as well. The problem, though, that there is no one specifically defined approach to actually do it. And there are different options, and based on the type of deployment, the model performance could be monitored. The hardest part to monitor is actually Azure Functions, because Azure Functions actually is stateless. And in our case, it just fire up, it's starting, and then it's dying. So literally, when the Azure function is done, there is nothing to monitor, literally. In case with a pipeline, you have the monitoring as during your model running, and giving predictions back, so during the inference. And then when the pipeline stopped, there is nothing to monitor further. So in case here, there are different options. It is always really, really hard to define the specific metrics that you're going to use to know that your model performs as expected. And also, based on the different setups, or you're doing everything in the cloud, or you're doing everything in hybrid, so parts in the cloud, parts on premises, or if you're doing everything on premises, there are different types of monitoring systems. There are different ways how to monitor, how to build a monitoring dashboard. And there are lots of different combinations. As well, there are some specific really good open source products available that you can use for model performance. And I also provided a really good link for explanation data and constant drift, so you can take a look at it. So also was a good explanation in the case with the time series data. So that's really, really important, because the time series data, because of their like temporal aspect, give you, it's a little bit harder to monitor because of the compute and the rest of the constraints. And the last part of it is exactly like the monitoring solution, and what is monitoring solution and how this monitoring solution should look like. Usually, what do you want to have? So if something happens, or on the level of system health, or on the level of your model performance, you want to be alerted on it. So there are different versions, different systems, different tools that could be used, like PagerDuties, just like sending emails, messages, like Azure Monitor, sending you some specific alerts where you can configure based on specific, you can set up basic specific thresholds, and if this threshold is achieved, then you get an alert. And as soon as you got the alert, that's where your logs come into place. So usually you're expecting the logs and you've seen what there. So what's probably triggered or caused this action? And the last step is act. Should it be a manual action? Should it be another type of action? So in the big lines, it could be, for example, the model performance is degraded, it's performing really bad, and there is an automated pipeline to retrain and redeploy a new model. Sometimes if it's really mission critical things, probably we don't want to do it automatically, we want a manual interference in it. There are different options, and there are a lot of companies that offer a different monitoring solution. In case with Azure, literally there is no out-of-the-box thing to do everything, but the combination of Azure Monitor with application insights help you to create specific dashboards, and based on your logs, you can then calculate specific metrics and set specific alerts and do specific inspection and decide how to act upon it. So another thing the last thing that I want to share about this part with machine learning system monitoring, the hardest part with it is that there is no way to set up perfect monitoring from the beginning. There will be some things that you will be seeing, and there are some new edge cases will pop up in the production environment. That's why we badly need monitoring and production environment to know what's happening there. So a lot of information again. I know, hold on, we are almost there, and you learn so much. You did a great job during the lesson 2 and the lesson 3. And during the lesson 1, of course, with all these installations. But now actually it's time to get back to the core of our bootcamp. And that's the time of the capstone. And I would like actually to invite Inge from Dexter to join the stage and tell us more about this Capstone Energy use case. And then I can pick it up later from your turn. Inge?
Thank you. Let me share my slides.
Of course. And I will stop sharing my slides for now. I do hope it works.
Yeah.
Welcome, Inge. Thank you so much for being here and delivering this awesome capstone case for us. I'm dying of curiosity. What is expected for our bootcamp participants? Tell us.
So you already saw me in the first training of this bootcamp. So I'm Inge van den Ende of Dexter. And now I'm going to tell you more about what we're going to do for the capstone. So really the case you're going to work on the coming weeks and bring all of everything you learned so far into practice. So I will first give a very brief recap of who we are at Dexter, what we're doing. And then I'm going to explain what you're actually going to do in the capstone. So at Dexter, we really want to take part in the renewable energy transition, so that and helping that by forecasting renewable energy, because the old fossil fueled energy, it's very predictable because you can also just choose how much you want to produce. But for renewable energy, it really depends on wind and it really depends on sun. So it's very important to forecast it. And the better you can forecast it, the more profitable it becomes. So we really want to help to make renewable energy as profitable as possible, and also to help to balance the grid, which is a real challenge of the energy transition. And in the first training, I gave more information about Dexter and also about working at Dexter. So if you're interested, you can watch that back on YouTube as well. And if you have any questions, don't hesitate to contact us. Here's our website. If you have questions about what we do, or if you have questions about working at Dexter, because we're still looking for a lot of people, especially with machine learning, Python skills. And it's a very dynamic and young group to work in with challenging topics. So if you're interested, let us know and we'd like to meet you. So now back to the case. So the case is really set in what we're going through right now with the whole world, to really go from the old energy system to a new one, where in the old energy system, you could just say, I want to consume this much energy. Okay, I'm going to adjust the amount of gas or the amount of coal that we burn to produce it. But that's not how it's working anymore with renewable energy. You really depend on the moments that there's sun, and you really depend on the moment that there's wind. Of course, part of it you can store, but you can never store everything. So you also will have to think about that you consume energy at the moments that it's there to help this transition. And this is super challenging, and therefore we selected this as the case and the capstone assignment for you. So the assignment for you is not going to be, of course, about the whole world, but it's going to be about a small village. It's called Pytown in the north of the Netherlands. And it's a very awesome village because they already have enough solar and wind turbines to produce enough renewable energy for themselves. So they're really not connected to any grid. They want to live fully on their own renewable energy. However, they do experience some problems with what I just mentioned, that the energy is not available at the moment that they want to use it. So they actually already spent all of their investment they had on having these solar panels and wind turbines. So they cannot build a lot of storage facilities. And they really notice that they use energy at the moments that there, for example, isn't enough sun or there isn't enough wind, and they have blackouts, and it's the order of the day, and they get super annoyed because they want to get around and they want to do their things, and it's a super big problem. So therefore they ask you in this capstone to help them with it. And to be able to, that people in PyChamp can adjust their consumption, if they can do that, then of course they can balance the grid and there will not be that much blackout. So if they just use the electricity, for example, they turn on their washing machine or they charge their car or they charge their electrical bike at the moment that there's a lot of sun or at moments that there's a lot of wind, then they're good to go. But they can only do that if they are informed, because otherwise they don't know when to do it, when to use the electricity besides looking outside and see that it's sunny. But that's a bit shaky. So they really need to have some information on how they start acting and balancing the grid. And you can help them with that, because if you have a dashboard that shows them what to do, then they're good to go. So, for example, you could show them 3 things. Go, you can use as much electricity as you want. Slow down, use a bit less than you normally do. Or stop, only use the electricity you absolutely need. So that can have a huge impact on the electricity demand of Python, because it really fluctuates, especially after a moment of stop. The go moment will mean that they use a lot of energy because they're going to charge everything they have again. And then they can try to live with only wind and solar energy. So this is actually the main goal of the capstone, and it will be divided in 2 parts. So the first task is to build the first solution they can use. This will be a weekly forecast, so they can see for the whole week when is the green moments in time, when is the red moments in time, when can I really use my energy. And in this, the end goal, as I already said in the previous slide, is on the right side in the monitoring. So really showing all the residents what they can do. And of course, also monitoring, but that's more for yourself, monitoring your model performance and your metrics. But to get there, you have to go to all the steps of the machine learning engineering process and apply everything you learned so far in this training. So really start at the data processing, which will combine 3 different data sources: energy and wind and solar and weather. Then train your model, which in this case will be a weekly model, and you can compare both a naive forecast and a linear regression with Fourier features. So the Fourier terms are really to capture seasonality. So for example, to have the daily pattern represented in your model. Then to evaluate which one is the best, you can optimize on the MAPE with the sliding window approach. And the MAPE is the mean average percentage error. And then when it's good enough for you to start deploying it, you can really deploy it. And in this case, you're going to do that in an Azure Machine Learning batch pipeline that you can just schedule at the moment that you want. In this case, Monday morning really early, so they can see at Monday morning what they're going to do this week in case of their energy usage. And then, of course, you have to post-process this data to get it to your dashboard and show it to everyone in Python. And this, I'm sure, is really going to help them to really reduce the number of blackouts. However, we think you will see that, of course, in your evaluation, but we think it's not going to help them with all the blackouts. So there's also one improvement step. That's the second capstone task. And that is to step more towards a real time. So it's not fully real time, but it's getting closer. So instead of having a weekly forecast, you can now make sure you have a forecast every 50 minutes. So that's really frequent. So they can really see the update on your weekly information every 50 minutes, which can capture way better the weather conditions at that moment. And in this case, you will actually use a simpler model than the eForecast. But what we generally see is that if you do your deployment faster, so you go closer and closer towards real time, the information gets better. So even a simple model can outperform a more complex model that has to be made further ahead. So that really shows that all the machine learning engineering skills that you now have, how valuable they are. That the faster it is, the better the information you got. So in this case, you will have only 2 data sources. The weather will not be available for the 50 minutes data. You also can practice with evaluating on an expanding window approach. That's here. And the deployment, of course, is really different because now it has to be not weekly, but every 50 minutes. So you will use an Azure function that is triggered when there's data available in your blob, and show it in your dashboard. So I assume that I hear it if there's any questions in the chat. So then if I don't hear any questions, I will wrap it up.
There's no questions. There's no questions, just previous from when Alyona was presenting.
I think everyone is so excited and they say, oh my God, we're learning how to deploy models, know how to build dashboards, what are we going to do?
I agree. They're mind blown and it's very interesting. Thank you.
So also later in Slack, you can, of course, ask all of your questions. So for now, then, if there's no questions, I just wish you really good luck. I'm really curious what you're going to do in this capstone case and what you're going to present. And enjoy.
Thanks, Inge. And okay, I will take the screen over. Just a second. Okay, are we good to go? The screen is there. So you just saw the presentation. The capstone is waiting for you, and at I just want to say blob storage, of course, at our GitHub. So that's all information about the capstone, the situation, the story, the challenges, and what I want to share here as the most important part is some basic capstone roles. So first of all, capstone is the team effort, and it's supported by mentors. So far we have 9 teams, we have 9 mentors, and from these 9 mentors, we have 9 teams. It's like 6-7 people, and then that's your time to split the work, to decide who is going to work on which part of the capstone, how to orchestrate all of it, and to see what you will be capable of delivering. And from starting from today, you have the data and the notebook as well here in the GitHub repository. And you have 2.5 weeks to work on the capstone as a team. What do we expect to get from it? So we expecting to have 1 GitHub repository per team. And that's, we want to see the code documentation on how you're going to do this. So how you're going to solve the problem of PyTown, how you're going to help them. And for dashboarding, it's not about building your own dashboards. That's why we decided to have a shortcut and just use a Power BI desktop version, free of charge version, just to showcase the output that is on your blob storage. And then the last thing left, there's exactly the presentation time. So on the 7th of August, it's Saturday, it's our presentation day. So what we expect one person from a team that's gonna present and teamwork. And you have 7 minutes, so it's 7th of August, 7 minutes, 9 teams, one person per team is gonna do presentation. What should be in the presentation? Share with us what you achieved with the team, what kind of challenges you faced, what are the biggest learnings, what's the biggest ups and downs. And then the next day, 8th of August, we have 9 GitHub repositories and we have 9 mentors. And that's where the mentors gonna give their written feedback. And all this information, all the Capstone rules could be found as well as the GitHub repository. So actually, what should I say? Good luck. I'm really looking forward to see what you will be capable of achieving. Remember that it's team effort. So remember that you can split the load, literally. You can parallelize some processes. And I think now we have a pair of minutes for questions. So Nancy, you mentioned that there was something in the chat.
Yeah.
Okay, so, fire up.
Laurens Benningshoff asks that he or she was not able to hear. You mentioned the guy with lessons.
Yeah.
I shared a link. I think it's the COM code.
Yes. It's a COM code. It's created by Vincent Warmerdam. He's right now working at Rasa and building the future of actually the Rasa chatbots. And it's his, literally it's his child, the COM code. It's a really cool project. And the link to the COM code, okay, thanks Nancy for sharing. And as well, the link for this project is in the information about the lesson 4 in the GitHub repository. It's there as well.
It is indeed a very nice website. I've also seen it, and even like the user interface is very well done.
Yeah, and it's also really, as I mentioned, it's really tiny pieces of wisdom with a short video explaining the concept step by step. And there are a lot of data science concepts explained in a really good way.
Yeah, all 4 phrases, super good.
Yeah.
And we don't have more questions for now, at least.
I think everybody just so excited with the use case.
They are programming.
Okay, cool. Also, what I want to share with you for the capstone, each one of you will be a detective, because what is waiting for you, you have only 1 notebook and you have 3 data sets. And you have some specific questions what you should do, but it's all really, really fuzzy. So please have your detective hat, wear it proudly, and we want to see how far you can go to actually help our village in the north of the Netherlands to become the first ever sustainable village that only consume wind and sun energy and consume it in the right time and the right moment. So I think that's the, I just want to say bewoners, oh my God, the, Nancy, how you say the people who live in the villagers.
Villagers.
So yeah, Pythonist probably. We are Pythonists and they're Pythonists. But I want to say citizens. Yes, I remember the word. So the citizens of the PyTown really can live without you. So right now they are only asking you to have this dashboard that probably will be, I don't know, like translated or will be broadcasted somewhere so they can use it. But just imagine how many things you can do. Probably it could be an application in the future. It could be some alerts that as a person, you can just receive an alert, don't charge the next 30 minutes, otherwise it will be blackout. But probably I'm just dreaming. I need to stop dreaming. And there is a lot of hard work that should be done. I probably, no, not probably, I'm pretty sure there will be a lot of questions about the use case. So the best way and the right way to ask questions. So first of all, have discussion with your team and with your mentor, and then come up with some questions that require clarification. If some requirements are fuzzy, if something not clear, you can find something, and then address these questions in our envelope channel on the PyLadies Slack. And as Inga mentioned, she will be there, but also be cautious. She will be not there 24 hours, 24 hours, 7 days per week. We need to balance the energy grid. So if there are some really specific questions, some unclarities, you can, of course, ask them, but try to bundle them. So to make sure that we are not dependent 100% on Inga answers. So I think that's it. Really looking forward to the next steps. Really thankful for all of you for being there with us. Now the time is actually started. You have 2.5 weeks, and we really looking forward to see your presentations at the 7th of August. And also probably you will be curious to get a mentor written feedback on your team's GitHub repositories as well. So Nancy, if there's no other questions, probably it can conclude our session for today.
Great. Thank you, everybody, for joining. Have a nice evening. Bye.